So before I get started on the main talk, I wanted to talk about something that I've noticed, something that surprised me. An awful lot of people have been sending me this picture recently since I started working on Cursive. And in fact, so today's your day, folks. You can actually give me some money for Cursive today. I opened it up for pre-sales today. Woo, thank you. It's very exciting. So it's just a pre-sale. The full release will be in about 2 weeks. So there's a 20% discount till then. You can pick it up. And something else to say about that is that Cursive does actually work with the community edition of IntelliJ. So that's free. It's open source. You don't need to buy IntelliJ to use Cursive. And Cursive will also be free for open source and non-commercial personal work. So things like student work, personal hacking, things like that. And I just wanted to say thanks to everyone for all the support while I've been developing Cursive. It's great. Cursive's the most fun I've had at work in a long, long time. And that's in large part because of the great feedback I get from everyone and the great support everyone gives me. So thanks very much. All right, but we're here today to talk about error messages, which are a totally different ballgame. So these, for a lot of people, are really like the pointy end of their experience with Clojure. It's one of the regular complaints that comes up for a lot of time, particularly with new users to Clojure, that the error messages are a bit incomprehensible, they're hard to figure out what's actually going on. So I was doing a bit of research while I was preparing for the talk, and I got the details from the 2014 State of Clojure, which is a survey of the Clojure ecosystem. And there were two free-form questions at the end that I was interested in. One was, name one language feature you'd like to see added. And so you can get all the data from that, and if you look at it and you look for error or stack trace, better communication of errors, better compiler error messages, better compiler error reporting, better error messages, and so on. This is a very, very common theme. There's a lot of people saying that they want better error messages in Clojure. Similarly, what do you think is the most glaring weakness or problem? Error debugging, error handling, error messages, error messages, error messages, error messages. This is a big problem for quite a lot of people, for new users, but also for very experienced users as well, I think. And so it's definitely something that I think it will be good to try and improve if we can. So I wanted particularly today to talk about macros and the error messages that come from them. So just a brief summary of what macros are for those who haven't used them very much. So macros are essentially a compiler plugin. It allows you as a Clojure developer to extend the language that you're using to write your programs. They're just normal Clojure functions. This is something that often gets lost, I think, when people are talking about how macros work. A macro is just a function, basically, and it's a function that's invoked by the compiler at compile time. So while the compiler is going through and doing its thing, it's reading your program. If it finds a form that is a macro invocation, what it will do is it will call the function, and it will pass it the macro invocation form, and then the macro will work out what that form does, and it will return another form to the compiler, which is what the compiler will use instead. And so what this is used, you'll see this referred to in like the scheme literature, for example, as language towers. So Clojure, the language, is actually a very, very small language. It only has, I can't remember, like 15 or 20 actual built-in forms, and a lot of what we think of as the Clojure language is actually macros in the standard library. And so you can think of a macro as a compiler really from one language to another slightly different language. One is Clojure with a particular macro form, and then after the macro has done its thing, it's a slightly more reduced version of Clojure that no longer needs that macro form because it's been expanded out into code that doesn't need it anymore. So the problem with macros, there are a couple of problems with macros as well as many benefits, obviously. But what I really wanted to look at today was how macros are actually parsed. So this is a macro that we're all pretty familiar with, at least familiar with using, is defen. And so I had to try and trim this a little bit to get it on the slide, but hopefully the important bit is there. So you can see that basically defen is just defined as a function, and it receives the form, which is the macro form of the defen that it's expanding. Env is your local variables, and then the various parameters are essentially destructuring the macro form into parameters that the macro will use to expand out, to create the expansion. And you can see there's a little bit of error checking there. We like to see that. So if name is if not a symbol, then we'll throw an error saying the first arg to defen must be a symbol. But the important bit I wanted to look at is in the let block there, where you can see how the macro is being parsed, and it's a very kind of manual process. So essentially the macro receives the form as a seek of Clojure forms, and it will just pick them out one by one. It will look at the first thing, is this what I'm looking for? Yes, no. If it is, it'll store it somewhere. And it's a very manual process. It's quite a laborious process. It's very, very tedious to write this code. I've written a lot of macro parsing code in my time while I've been working on Cursive. It's very, it's not fun code to write, and it's very difficult to achieve reusability with this code. So if you look at the implementation of def macro, for example, def macro has almost exactly the same shape as defin. And in fact, the parsing code is very, very similar, but it's not quite the same. It's not quite an exact copy-paste, but it's, there's very little reusability between those two functions. But most importantly, it's very, very brittle, this code. So the code tends to make very, very strong assumptions about what it's given. The code basically assumes it's given a valid defin form, and it will pick it apart with those assumptions. And if the input doesn't actually conform to what it's expecting, then you'll get some really, really crazy errors. You'll get errors about can't cast character to iSeek, something like that. And critically, the error message will actually come from the compiler code. So the error message is often almost completely useless to the user in terms of actually trying to figure out where in the user's code things actually went wrong. So here's an example, again, of a macro that we're all quite familiar with, and a macro that doesn't actually check its arguments very well. So we can see in the first example there, illegal argument exception, parameter declaration arg1 should be a vector. And so this is an error that someone might make if they were coming from Scheme or Common Lisp, where they use round parentheses much more frequently than in Clojure, where we tend to use square brackets of vectors for our arg forms. And this error is going to be quite confusing for someone from that background. You'd be like, arg1 is an argument. Why does it need to be a vector? So what's actually happened there is that defin is going through its parsing, and it's reached the arg1, arg2 list. And defin actually comes in two flavors. So it has a singularity form where you say defin myfn, and then you give it a vector of parameters. Or you can have a multi-arity form where you give it a series of lists, and the first element of each of those lists is a vector, which are actually the parameters for that arity. And so what's actually happened is Clojure has actually seen that it's a list. It's assumed it's a multi-arity form, which is not what the user intended in this case. And it's given an error message relating to that. And again, note that the error message itself comes from core.clj, that's Clojure core line 6567. And if you look at the whole stack trace of that, it's almost totally useless to the user in trying to figure out what's actually going on. And so there are a couple of other examples here. The second example there, again, it thinks it's parsing a multi-arity vector, which looks pretty plausible in this case because that's what the first thing is. But when it's got to the second element there, which is the vector AB, it's just assumed that since it's parsing a multi-arity form, it's going to be given a list, and it hasn't checked that it actually is a list. And so now it thinks that A is going to be the parameter, and it's not a vector, so it's complaining about that. Defin foo A, don't know how to create iSeek from Clojure lang symbol. I mean, who knows what it's thinking, right? Bad docstring, again, don't know how to create iSeek from Clojure lang symbol. The only way to figure out why these messages are coming out is to look at the implementation of the macro and to see what's going on. And again, these are not useful error messages for the user. Defin test name, it goes ahead and defines a var. Who knows what it has in it. And then the last one is just a misplaced map. Now you might be thinking, I use defin quite a lot, and I'm sure the error messages are better than this. And in fact, you're right, because there was this fantastic JIRA in Clojure 1.5, CLJ 157. Need bit error report when omitting parameter list from fn or defin. It sounds like exactly what you want. So the description is somehow I just forgot to define parameters for my zero argument function, and it took me a long time to notice it, mostly because I've been working with a lot of macros, but especially because I didn't get an error that said you must provide a list of parameter names, but instead don't know how to create iSeek from symbol. And this is an experienced user. This bug was filed by Ambrose Bonnet-Sargent, who wrote core typed. So while these errors are particularly difficult for newcomers to Clojure, experienced programmers have problems with these as well. But this is a great JIRA, so here's what the error messages look like afterwards. In the first one, the error message is actually almost exactly the same, but critically the error now shows where in the user's code the problem is. So you can click on that link if you're using Cider or Cursive or something, or you can just go and look it up in the file, and it will tell you where the problem actually is, and it's much, much easier to figure out what's going on. And there are much better error messages for these other cases. Invalid signature AB should be a list, parameter A should be a vector, it doesn't accept just def and test name, first argument must be a symbol, and so on. So the error messages are much, much better after this JIRA. But I wanted to comment a few things about this JIRA. Firstly, its priority was minor. I'll just leave that there without further comment. It took 3 years for this JIRA to be fixed, from the time it was filed to the time it came out. And it wasn't like it was just sitting there languishing. There was quite a lot of activity on the JIRA in this time. So these are all the people who are involved in fixing it. You probably recognize most or all of them. They're the people who are implementing Clojure, who are working on Clojure. They're implementing significant Clojure libraries. And they're spending quite a lot of time on this JIRA. There's a lot of discussion. And in fact, so they didn't just have a single comment each, there were actually a whole bunch of comments. And a lot of this was a sort of back and forth. A lot of it was discussion of regression impact about fixing these things, so pathological cases that used to be accepted by the compiler and now throw errors, which you do, you need to be discussing that stuff while you're actually doing this, because you need to assess the regression impact. And some of these comments were also just the workflow of the JIRA. So, okay, now it's screened, now it's vetted, and so on. But it took a lot of time to go through and to figure out how these changes should work, what the changes should be. And after all that work, we fixed 3 cases in 1 macro. And defn isn't actually even a very complicated macro. It's a relatively simple one, like the NS form. I mean, that thing's huge, and I mean, there's an awful lot of unhappy paths through the NS macro while you're parsing it. But these things are getting better. So if you look at the release notes for different Clojure versions, there's actually a separate section always in the release notes for improvements to the error messages. So Clojure 1.8, there were 4 improvements there. Clojure 1.7, there were 2. Clojure 1.6, there were 6 of them. But again, when you look at these fixes, they're very, very specific. So similar to the defn, they fix very, very specific cases that have cropped up. And presumably each of these requires a reasonable amount of work to get it through and vet it and whatnot. And there's plenty more where these came from, right? So there's currently 39 JIRAs open just with the tag error messages. So we're going to be fixing these things for a long time, I think, and I think we probably need a better approach. I think while I think everyone agrees that that JIRA is fantastic, it was a great result. The error messages are much, much better as a result of it. Hopefully it's not too controversial to say that I think the ROI on the amount of investment that went into it is maybe not as great as we might hope. So Cursive, I spoke a bit about this at the College last year, about how Cursive works. Basically, Cursive, unlike most other Clojure editors, doesn't use the REPL for its editor functionality. So most Clojure editors, they're sort of continuously talking to the REPL while you're editing to provide the editor functionality that you want. So things like navigation, it will go out to the REPL and it will introspect the var that you're trying to jump to get the metadata off it to see where it needs to go. Similarly with documentation and whatnot. Cursive doesn't actually do that. So Cursive actually works by analyzing the unexpanded source. So it quite deliberately chooses not to use the REPL, and it also deliberately chooses not to expand macros for various reasons that I won't go into now. So this means that it needs to understand what macros mean, and it really means that it needs to parse the macros in much the same way as the actual macros themselves do. So when I first started out writing Cursive and I started implementing support for a lot of these macros, the core built-in macros, I parsed them all by hand. So I had very similar code to what the macros themselves have. I wrote macro parsing code for nearly all the core macros that Cursive supports, which is most of them these days. And in really complicated cases like the NS macro, I mean, there's an awful lot of edge cases in the NS macro because it's a combination of a whole bunch of different macros or functions all bundled together. And there was no way I could capture all the edge cases by writing code myself. So I just basically copied the code from Clojure core into the Cursive code base. I modified the Cursive AST elements so that they mimicked as closely as possible the elements from Clojure core. And that basically helped with the porting of that code from the original Clojure core code to do something similar with the Cursive AST. But it was really no fun, right? It was not, it was difficult work, it was quite tedious to do, and it was very, very hard to get it right. So in a compiler, particularly when you're starting out, you can kind of punt on error messages a little bit. You can say, well, you know, I'm just going to assume that you're giving me valid input, and if you're not, I'll just do something a bit crazy with it. So, and Clojure is a compiler, even though it doesn't seem like it. Sometimes while you're in the REPL, you're working interactively. There's no interpretation ever happens with Clojure. So it receives a form, it will basically parse and compile a top-level form at a time, and then it will execute it. So in an editor, the AST is continually broken while the user is working on it. So it's like the normal state, right? You can't assume that the input you're going to be given is good. And so the macro parsing problem is much worse. So what I found was I was getting similar error messages to the sorts of things that we saw earlier from standard macro expansions. Users were getting those all the time while they were editing code in Cursive, because the AST is broken while you're working on it, right? While you're writing out your NS form or your defin, it's missing parts that it needs that you haven't filled in yet. And so the macro parsing problem is much, much worse because it's continuous and the user sees it all the time. But it is still the same problem, and I think that the fixes that, the sorts of fixes that I ended up with using in Cursive could also be used in the compiler, and I think that would make the compiler error messages much better. So I thought quite a lot about how to actually fix this. I was eventually tipped over the edge when I was implementing core type support, which has very, very large complex macros. There's a lot of optional parts to them. Writing the code to parse them is really quite difficult. So in the end, I figured, well, I'm parsing things, I should just write a parser. And that was what I did. So the initial implementation was a fairly simple parser. It used the semantics of Parsing Expression Grammars, which I'll talk about in a little bit. It took, like, the initial version literally took me an afternoon. It was 200 lines of code, and it just saved my life. I can't describe how much better it made my life, this change. So parsing expression grammars, they're a simple recognition-based formalism, so to describe a top-down parser with backtracking. So the fact that it's recognition-based means that basically they were designed to be used in parsers. And so essentially, you give it a bunch of rules, and it will try and parse something. If it can't, it will then backtrack and try another alternative. So in theory, the backtracking can lead to exponential time with the parsing. In practice, that doesn't actually happen very much. Even complex grammars only tend, for machine-oriented languages, pegs aren't very well suited to natural language. But because the backtracking is quite limited, I'll show you in a moment how that works. The backtracking only goes back to quite fixed points. In practice, it's actually quite easy to handle. And you can also use memoization with these. That's called a pack-rack parser, where essentially it will use memoization for the intermediate results, and then you get guaranteed linear time while you're parsing at the expense of memory. So again, in the worst case, in a pathological case, the memory use can be exponential, but again, in practice, that basically never happens for computer-oriented, machine-oriented languages. And one other interesting feature of these grammars is that there's no ambiguity, and ambiguity is never introduced because it uses what's called an ordered choice operator. So these are the basic operators in a peg. If you've used any sort of grammar before, BNF, or anything like that, or even if you've used regular expressions, it's pretty similar basically. So you can group expressions, you can have optional elements, you can have 0 or more. The negative look ahead, what that will do is from your current point, it will try and parse ahead, and if it succeeds in parsing, then the parser will fail. So that's it's sort of a way of saying, I'm not looking at this particular expression. And then the ordered choice operator is the main thing that kind of distinguishes pegs from a lot of other grammar things. And so basically, it will try and parse the first expression. If that succeeds, then you're done. That's your result. If it doesn't succeed, then you try the second or third alternative. You go through the alternatives. And that's how you avoid the ambiguity, basically. So essentially, the burden is on the programmer to ensure that your grammar is not ambiguous. So you need to ensure, basically, that none of your earlier cases will ever shadow your later ones. But not having ambiguity is actually a really nice feature in a parser. And again, you can sequence them, which is just you parse the first expression, then the second one. So this is an initial version of how the code actually turned out in Cursive. So on the left there, you can see an example of what the grammar actually looks like. So at the bottom there is the pattern for defen. So these patterns assume that they implicitly receive a list, because all macro forms are lists in Clojure. So a defen starts with a symbol, which is the defen itself, and then it has another symbol, which is the name symbol. So you can see there where it says symbol as name symbol. That's actually just a simple capturing mechanism. So the way these parsers work is you'll give it a form, you'll try and parse it. If the parse is successful, it will return you back a data structure with all the elements that you picked out of the form as you were parsing it. And so the two basic ways to do that are, you can see that there's symbol as name symbol, so that will just take the symbol and it will put it in the map using the key name symbol. Or further up, you can see an into declaration, and that assumes that there's going to be multiple of these things, so it will create a vector and just put them in, so you get a series of these things back. So the grammar is reasonably straightforward. I mean, defen is a symbol, which is the defen symbol, followed by the name symbol. Then you have an optional doc string, you have an optional param map, then you have some arities. So the one thing that it might need a bit of explanation is the item. So again, because you're receiving a data structure back, you can use item to create nested maps within that data structure. So item just basically creates a new map for some sort of sub-element of what you're parsing, and then the sub-parsers to item, the things that it captures will go into that second map. And then so on. So you can see in the arities, there's an alternate there between the singularity form and the multi-arity form, but hopefully it's reasonably simple to understand what's actually going on there. And there's an example of a parse on the right there. So there's a simple function, defen test fn with a doc string, uses a little bit of destructuring there, and you can see the data structure that the parser will return at the bottom. So it's picked the various pieces out as it's parsing through. So it gives you the name symbol, it gives you the doc string, you get a vector of your arities, and then you get some information about the arities. You get the arg list. So they're the parameters. That's actually two elements. It's a vector and a symbol. So that's used. Cursive actually does arity checking. So the parameters element there will tell you what the arity of the function is, how many things you need to parse it. Targets is slightly different. That is all the local variables that are declared by this function. And that's actually slightly different here because we're using destructuring. So there are actually 3 local variables, even though because we're destructuring them, even though the function actually only has arity 2. And this change was massive. I mean, I can't describe how much this improved my life. And it improved the lives of all the Cursive users as well, because they were used to getting these sort of random crazy exceptions while they were editing their source code, and all of a sudden, everything became much more robust. Basically, these parsers were still quite simple. They would essentially just fail if the input didn't match the grammar. But that's okay. It's better than some exception, right? So what would basically happen is that it would be quite obvious because Cursive wouldn't be able to resolve symbols inside the macro form, but it still didn't actually show you where the errors were. But even so, the grammars are much more readable, I think, than the equivalent hand parsing code. The hand parsing code, especially when you look at some of the larger macros, is extremely complicated. And they're quite difficult to maintain as well. If you suddenly want to change a little bit about how the macro is parsed in the middle of the form, that code is quite difficult to maintain. So in contrast to someone who's writing new macros, for Cursive I actually have to write parsers for existing macro forms. So I basically tend to look at the documentation, see what the documentation says the macro looks like, then I look at a bunch of examples and see what the macro actually looks like, and then I make the grammar based on those. And these grammars are much, much easier to develop based on a bunch of examples and some documentation than writing the code by hand. They're much faster to write. So even for a complicated form, like something like the core typed macros, they have a lot of optional parts. They're quite complicated. I can sit down now with a little bit of experience, and like half an hour, I can come up with a grammar for a very complicated form, and I can be reasonably confident that it's actually correct. They're very easy. And there's a lot of reuse you get there as well, because if we look at the grammar here again, you can see that the parameters, so these are just functions here basically, so you can compose them, you can reuse them however you like. And so parameters is actually called twice there, but that parameters little chunk of grammar is actually reused any time that you need to parse a list of parameters for something that under the hood is going to be destructured down to an FN form, right? So that's definite and a bunch of other things as well. But you don't just get a lot of reuse in the grammars, I found, which actually surprised me. So the fact that you're separating the parsing out from the processing, and those data structures really form a data API between the parsing process and whatever you're actually doing with the results of the parsing. In my case, I'm creating indices and whatnot, but code generation would be basically the same thing. And that data API actually allows a surprising amount of code reuse. So for example, defen and fn semantically are actually pretty similar, because defen really desugars down to just def and an fn. It takes it basically takes, it creates an anonymous function and sticks it in a var. That's basically what defen does. And so the fact that if I can create the parsers such that they create the same data structure from a defen and an fn, even though the syntax is different, then I can just use the same backend code for both. And this was actually really useful in core typed as well, because core type has like an old style syntax and a new style syntax. Ambrose changed it a while back. So I just need a different parser for the two different syntaxes, but as long as they produce the same intermediate data structure, then the backend code or the processing code is the same. So I was extremely pleased with myself. I thought I'd invented the best thing since sliced bread. And so I sent it off to Ambrose, who was working on core type, and he was suitably impressed. And I sent it off to Colin Jones, who at the time was writing the book on Clojure macros, and he said, "Oh, that looks like illuminated macros." And I was like, "What?" And it turns out that 2 years ago at the Conj, Chowser and Jonathan Claggett gave basically this exact talk, talking about how we should be using grammars to parse our macros because it's great, right? And their work was based on a paper called Fortifying Macros, and this is a paper relating to Racket. And actually at the Conj last year, after I'd spoken about Cursive and how it parsed a lot of macros, I was speaking to Will Bird afterward, and he said, "Oh, you should check out this syntax parse thing that they did." And I didn't listen to him because I'm a moron, obviously. And that turns out to be what Fortifying Macros talks about. And so 5 years ago, they had a great solution to this problem, and they've been doing it for ages. So the lesson is always look at the scheme thing, folks, to see what they're up to, because they do a lot of really cool stuff. But I also wanted better error handling. So when the form wasn't correct, I wanted to be able to help the user to figure out what was going on. So top-down parsers usually have good support for this, because essentially you start at the top and you parse down recursively through your different forms. So when you reach something that you don't understand, you have quite a lot of context to explain to the user what you were trying to do, what you thought was going on, and you can use that to provide pretty good error messages. Pegs make that a bit more complicated because they backtrack. So what that means is that for any given peg parser, if it can't match the input, that's not necessarily a catastrophic failure. It doesn't necessarily mean the input is bad. What it means is you have to backtrack to your previous alternation and try another option. So this sort of dual failure mode of pegs actually complicates error handling a little bit. What you will tend to get, so if you imagine what a peg for something like JSON would look like, a simplified JSON. So at the top level, you would say a JSON object is, maybe it's a string or a number or a JSON object or a list. And then a JSON object would be some curly braces followed by one JSON object, which is the key of the JSON object, which is the value, and so on. So a peg, if you give it a big JSON document and there's an error halfway through it, it will parse through it. But then when it reaches a failure, a naive implementation will just backtrack through the various alternates, and then it will basically say, at the beginning of your document, I tried to parse a JSON document and I couldn't, which is not very useful. I would say I couldn't match either a JSON object or a string or a list or a number. It's not any of those things. And it doesn't really help. So the usual heuristic here is while you're parsing, you keep track of how far you got with each of your alternates. And then you assume that the furthest point you got to is where the error actually is. And so when one of your parsers fails, you basically, at the point it fails, you maintain how far through the input you were, and you record a bunch of context, and then you can use that later to give pretty good error messages. So here is a slightly modified form of the grammar, which just to help the error messages. So pretty much the only thing that's been added there is it has these called forms here, and that's just used to provide a human readable error message. Excuse me. So I'm going to show you a demo now. I followed a strict TDD philosophy while I was developing this demo, which is talk-driven development. I thought it would be an excellent idea to propose a talk about something that I'd done quite a bit of research on but hadn't actually implemented. That turns out to be a terrible idea. Don't do that. I got extremely busy with other things, so I didn't actually have as much time to work on this as I would have liked. And so the main thing is that this is not actually in the public cursive version yet. This is still just a proof of concept. But as you'll see, it actually works pretty well. So here I have my cursive REPL. I'll just load that namespace and switch into it. So here are these macro forms that we saw before, and this is Clojure 1.7, so actually that's a little bit small, unfortunately. So you can see these are the better error messages produced by the more recent forms of, more recent versions of Clojure. And again, that's a bit small, unfortunately, sorry, but so these error messages here. And there are some other cases down here as well. So here are some other things that I basically picked off the mailing list while I was looking for different options. So while I was preparing for this talk, I went through the mailing list and I looked for people who were complaining about error messages to see what the sorts of things were that were bothering them. So here's an example here that would be quite a common case for a new user to Clojure. When you're using the NS form, it's quite difficult sometimes to work out. When you're in the REPL, you have to quote things, and then when you put it in your NS form, you don't have to quote it anymore. And so here, if the user actually forgets about this and they put it in, they get this error message here. Class not found, quote, dot, open parentheses, nl.bitwork or something. No class name I've ever seen has a parentheses in it, but it's, so it gets this crazy error message that for a new user, this is quite a common mistake, or an easy mistake to make at least, and that error message is not particularly useful. So the user might go through and try and fix it, and then they would try this here, for example, and the compiler accepts that perfectly well. And you go to the test2 namespace and you say, and it's not there. And so what's up with that? And again, this is a very confusing case for a user because they think they fixed their problem, the Clojure compiler said it was okay, but in fact when it loaded in, it didn't do anything. So the way this works is that the import form here, if you want to import this class, you either have to do it like this, so you're essentially importing the package and then the class separately, and you can use that to import multiple classes from a single package. Or you need to do it like that and just import a single class. But for someone who isn't very familiar with Clojure, is getting started, or even just an experienced user who makes a mistake, that's quite a subtle error, and it can be quite confusing to know what's going on. And there are various other cases down here. So here is what this looks like in cursive now. So I can now mark these errors right in here, and this actually shows you exactly where the error occurs. So again, because I'm parsing through the forms, I know where it failed, I know which form it failed on. I can actually show the error right on the place. And the error message is actually pretty good. Like when you look at it, unexpected symbol arg1, expected parameter vector, that's actually almost exactly the error message that was handwritten from the Clojure compiler. But these error messages are automatically generated. The only thing that's required to get these error messages is just to annotate the grammar with some friendly names for the particular things that it's looking for. So parameter vector is just a friendly name. Otherwise, it would just say vector because it only knows the type of what you're looking for. And again, these cases here, the error messages, I think, are at least as good as the handwritten ones, and sometimes they're better. So it's saying here, expected a doc string, an attribute map, a parameter vector. So again, the parser knows all the possible things that might actually be present there, and it can show you these cases. And it catches all these cases. And importantly, I didn't really have to do anything to actually do this. I'm already parsing the forms. I know what the shape of the forms is. I really didn't have to do any work. The only work I had to do for this demo was actually implement showing the errors. I had to implement the error handling, which I didn't have previously, and then just show the errors in the editor. But now, for any new grammar that I develop, I'll get these errors automatically for free. And it shows these things here: unexpected quoted form, expected sequential form or a symbol. Again, in the NS form, I haven't actually gone through and given it the friendly name, so I can make the error message a bit better. And the same thing here, expect a symbol at the end. So there are some other things here that some other cases that it catches. The documentation for NS says that references in the NS form have to be one of or zero or more of refer, Clojure, require, use, import, load, whatever. That's actually a total lie. I'll accept pretty much anything you give it. And you can put an eval in there if you want. It'll do that as well, quite happily. Cursive marks that as an error. I guess it's a little bit arguable as to whether that's actually an error or not, given that Clojure actually accepts it. It is actually valid. I'm going to leave it as an error because I don't think you should be doing that. So there are some other cases here that it catches. Previously, Clojure, for example, when you say quote 1, 2, 3, it will just return you a 1, but you've actually passed it multiple things to quote there, which didn't expect. Same with var. Some other cases that I found on the mailing lists here, someone had left their full stop outside their dot comment. So this is much, much nicer, basically. It's much easier for the user. And again, these are updated dynamically as you're editing, so it's very easy to see what's going on. Right. But I know there's at least someone out there thinking, oh, but IDEs suck and cursive sucks, and this looks nice, but I don't want to use it. So, but it's okay, random internet hater person, I've got your back. So just to show that there's nothing up my sleeves, this is just a standard line ripple, so I can do install the goodness here. Right, and I'll just do function that always returns 10, right? That's always useful. So defen works just like it always did previously. But now I get these same error messages that I got in the Cursive Editor here. So none of this is specific to Cursive, right? I developed this because I wanted better error messages in Cursive. Thank you. But you can use this for normal Clojure code. So this could be used just to create, if you didn't want the cost of validating all your built-in forms while you're running in production, there's no runtime cost to these, right? There's a load time cost. So it's only while your code is being parsed and the macros are being expanded that there's any cost at all to this. Once the macro has actually been expanded and compiled, there's no runtime cost at all to these error messages. And I think these make a big difference. And so, again, we can do some bad things here to the NS form, and it will give you these error messages. So all those cases you saw in the editor work fine here. And I think there's quite a lot of scope here for, so this the way this works is it essentially monkey patches defen and NS. It uses altovar root on the macro. And so what it will do is it will parse the form that it's given, and assuming the parse returns no error messages, then it will just call the original. So it's a reasonably low impact form. Right, so where's my keynote gone? So just a little bit of inspiration before I finish. There's a fantastic blog post here. I recommend people read it. I've got a huge geek crush on Evan Zablicki, who makes Elm. He's a very thoughtful guy, I think. He writes a lot of stuff about Elm, but I think a lot of it is about programming in general and about implementation of programming languages in general. And I think we could learn quite a lot from him, even if we're not using Elm. So he talks there about how he sat down to think about error messages, and just by really focusing on what the user experience of the error messages is, he got some really dramatic improvements. And he had some examples there in his blog post. It's a little bit difficult to see on the projector, sorry. But so on the left is the code, and on the right-hand side is the error message from the bad code. So it actually shows your exact line of code as it appears in your source code. So this isn't some pretty printed thing from the AST that the compiler has. It actually has the actual source code in there, and it shows you exactly where the error happened. It gives you some sort of friendly hints. It has a database of errors, and it tries to figure out, based on the error message you got, what it thinks you were trying to do, and it shows you some ideas there. And it uses a little bit of color and layout to make these errors friendlier. So the Elm takes error message handling very seriously. They actually have an error message catalog, which is a GitHub repo where people can upload snippets of things that they got crazy errors for so that they can analyze them and try and figure it out. I think this is a fantastic idea. It also produces JSON errors for tool consumption and things like that. There's an open question as to whether it actually helps adoption. A few people have said to me, well, okay, that's all very nice, but no one actually uses Elm and tons of people use Clojure, so maybe this isn't actually a problem, right? To which I would answer that's kind of a depressing argument, and just like saying, you know, we're sort of mediocre enough that no one complains. But you know, I think it's something we should be trying to improve, right? So I'm not actually sure whether it helps adoption or not, but it kind of feels like it should, and it feels like something that would be nice to do for our users. Thank you very much.